Yeah. No, like, bro. That's all you can say.
All right, so this is limits of rational functions. So yesterday we were talking about if it's not possible to substitute the number into a rational function because you get a zero denominator, then the first thing you should try and do is, if you get a 0 over 0, that means there's a hole in the function, so you should try and factor the top and bottom, cancel common factors, then try again. Any questions on those? Okay, let's try a different type of problem. What if you have something like the limit, find the limit as x goes to 3, x goes to 2, of x plus 3 squared minus 25 over x minus 2. All right, so in this case, you definitely get 0 over 0, right? If you substitute 2 into the top, you get 5 squared minus 25. And if you substitute 2 into the bottom, you get 2 minus 2. What do you think you should do in a situation like this? So the fact that you get 0 over 0 should alert you to the fact that this function has a hole in it at 2. That's what that means.
Right.
How do you find the y coordinate of the hole in this case? You can't. If you substitute 2 in, it gives you 0 over 0. Okay, yeah, let's try that. Let's square this. If you square x plus 3, you get x squared plus 6x plus 9 minus 25 over x minus 2. Well, the problem is if I substitute 2 in, I still get 0. I get 4 plus 12 plus 9. That's 25 minus 25. And in the bottom, I still get 0. Great idea. Great idea. So this would be the limit as x goes to 2. You can combine like terms here. You get x squared plus 6x minus 16 over x minus 2. Now it's just like yesterday's type of problem, right? You get 0 over 0, but now you can factor the top. The top would factor as two numbers that multiply to give you negative 16 and add to give you 6 would be x plus 8, x minus 2, and then the x minus 2's cancel. Now you can just substitute 2 in for x, you get 10. That's the answer. So in a situation like this, the factoring was kind of hidden by other algebra type things that you can easily take care of just by FOILing, getting rid of parentheses, combining like terms. Then you end up with just a really simple rational function that can be factored. Does everybody understand that? Let's try another one where other algebra is necessary. How about something like this? The limit as x goes to 3 of 1 over x minus 1/3 over x minus 3. So for sure, you get 0 over 0, right? If you substitute 3 in, you get 1/3 minus 1/3 on top, and you get 3 minus 3 on the bottom. That's 0 over 0. So brain says that's a hole in the function. So now our goal is to do some algebra to figure out how to identify the y coordinate of that hole, because that's the answer to this problem. What can we do algebraically in a situation like this? Remember, this is a complex fraction. We did this earlier in the year. What can you do algebraically to a complex fraction? A fraction which contains other fractions. Yeah, you can take the top and multiply it by the reciprocal of the bottom. But before we do that, we need to get the top to be a single fraction, right? Remember that? So we can get a common denominator on top, 3x. So I need to multiply this piece by 3 and this piece by x, then I could take, limit as x goes to 3, I could take the top, the whole top fraction, which is just 3 minus x over 3x when I simplify it, times the reciprocal of the bottom, 1 over x minus 3. Now we're back into yesterday's type of problem. It's already factored though. I could just cancel these as a negative, right? Because it's 3 minus x and x minus 3. They don't cancel as 1. They cancel as negative 1. And now I can just substitute 3 in. There's no problem anymore. This just ends up giving me negative 1 over 9. Everybody follow that? Let's try another one of these. How about the limit as x goes to 0 of 1 over 2 plus x minus a half over x. Same exact situation. On the top, I have 1/2 minus 1/2 if I plug in x equals 0. And on the bottom, I get 0. So same issue. The bottom's good. It's already a fraction, but the top's not. I need a common denominator. What should be the common denominator on the top terms? Yeah, you just multiply them together, right? So I need to multiply this by 2, and I need to multiply this by 2 plus x. So if you look at the whole top here, the whole top is just, let me write limit as x goes to 0. The whole top is just this top minus this top. So you have to be careful about minus signs. It's minus 2 minus x over 2 times 2 plus x. That's the whole top, right? Times the reciprocal of the bottom. Well, look, 2 minus 2, that's nice and convenient. So all that's left on top is negative x. There's an x right there. This x and that x can cancel because it's a common factor. And now you just have a negative 1 left on top. So the answer is negative 1 over 2 times 2 plus 0. 2 times 2. The answer is negative 1/4. So it was possible to do a little bit of algebra to get rid of the common factor. It wasn't as simple of a situation as here's a polynomial, here's another polynomial, they're both 0, factor them and get the common factor. It was more algebra involved in that. We okay so far? Okay, let's try a different type of problem. What about something like this? The limit as x goes to 4 of x minus 4 over radical x minus 2. What do you get when you substitute 4 in? 0 over 0, which is not 0. It's 0 over 0, right? Which your brain should say, that means that there's a hole in this function at 4. So we have to do some algebra to figure out what the y-coordinate of the hole is. Any ideas here? All right, let's go back into memory land. Remember, if you have a fraction with an irrational denominator, like for example, 1 over the square root of 2, and you wanted to rationalize that denominator, what did you have to do? Yeah, you could just multiply this by radical 2, multiply this by radical 2, and this ended up being radical 2 over 2. And that's like the rationalized version of that, because the denominator now is not irrational. And a long time ago, the Greeks decided that it was not good to have irrational denominators for some reason. But we're stuck with their decision. Okay?
Thank you, Greeks.
Yeah. Damn Greeks. Again.
Then we would multiply by like the square root of x.
Well, not exactly, because what if the denominator is slightly more complicated yet still irrational, like something like 3 over radical 2 plus 5 or something like that? Then what do? I can't hear.
So couldn't you multiply everything by radical 2, like including?
Well, if I multiplied everything by radical 2, it would make a radical 2 on this term then. And that doesn't really help. Yeah. Do you remember what to do? Starts with
You have to like put the denominator first into the numerator or something, right? You can like paddling around.
I don't know. It starts with a C. Say it again. Yeah, you multiply by the conjugate of the bottom. You remember that?
Okay.
So you're going to take the bottom, which is radical 2 plus 5, and you're going to make that plus sign a minus. So you're going to multiply the top and bottom by radical 2 minus 5. You gotta remember that?
Barely.
So then on top, you have to like distribute the 3. So you get 3 radical 2 minus 15. And on the bottom, you'd have to FOIL it out. But just by multiplying a binomial by its conjugate, it gets rid of the inside and outside terms when you do the FOIL. Like if I do the FOIL here, I get 2 minus 5 radical 2 plus 5 radical 2 minus 25. Like all the irrational stuff cancels. That'll always happen when you multiply a binomial by its conjugate. Inside and outside terms will always cancel. So this just ends up being 3 radical 2 minus 15 over 2 minus 25, which is negative 23. So that's the answer. This is considered, for some reason, simpler than that. It makes no sense. But anyway, this is a rational denominator. So this is considered like rationalized, simplified. And this is an irrational denominator, so that's like, nope, can't have that. But this is the answer. If you plug this into your calculator, let's do it. If I take 3 divided by, parentheses, radical 2 plus 5, you get a decimal answer. And if I take this and do the same thing, 3 radical 2 minus 15, all divided by negative 23, and get a decimal answer, you get the exact same decimal answer. These are totally equivalent to each other, but this one's better than that because it has a rationalized denominator. Kind of remember that? Okay, so back to what we're doing. We can actually do that process here to get rid of the radical. You can multiply the top and bottom by the conjugate of the bottom. Radical 2 plus, or radical x plus 2. Now, I'm not going to FOIL out the top. That's just going to make things messy, and it's going to hide something important. I'm only going to FOIL out the bottom. So this is going to be the limit as x goes to 4. I'm going to keep the top as the product of these two things. X minus 4 times radical x plus 2. But the bottom, I'm going to FOIL. If you FOIL the bottom, you get x plus 2 radical x minus 2 radical x. Those both cancel. Minus 4. Notice anything? Yeah, there's an x minus 4 here. So that's what I said. That's what I meant when I said it would hide something. If I FOILed the top out, it hides that x minus 4 that so conveniently cancels with that x minus 4. Now I can just substitute 4 in, and there's no problem anymore. If I substitute 4 in, I get 2 plus 2. The answer is 4. So this rationalization process can work to reveal common factors sometimes. All right, let's do another one of those. Sometimes you have to actually rationalize the numerator. Let me show you what I mean. What if you have something like the limit as x goes to 7 of radical x plus 2 minus 3 over x minus 7. If I substitute 7 in, I get radical 9 minus 3, which is 0 on the top, and I get 7 minus 7, which is 0 on the bottom. So this doesn't like obviously factor in any way, right? So I'm going to try this rationalization process, but this time the radical appears on top, so that's the part that I'm going to rationalize. I'm going to multiply the top and bottom by the conjugate of the top. So the conjugate of the top, you change this negative sign. You don't change that sign, you only change this sign. So it's going to multiply by x plus 2 plus 3. Radical x plus 2 plus 3. On both the top and bottom. And this time, since the top is what I'm trying to rationalize, I'm only going to FOIL the top. I'm not going to FOIL the bottom out. So if I FOIL the top out, I get radical x plus 2 times radical x plus 2, which is just x plus 2. Then if you look at the inside and outside terms, you get plus 3 radical x plus 2 minus 3 radical x plus 2. They cancel. They always will. And then minus 9. On the bottom, I have x minus 7 times the square root of x plus 2 plus 3.
So then it's just 1 over x plus the root of x plus 2.
Yeah, this is really just x minus 7. How convenient. It cancels with this one.
How convenient.
So this ends up being 1 over, now I can plug 7 in without any consequences. It's radical 9 plus 3, 6. The answer is 1/6. Let's do another one. These are a little complicated.
So like, how is it that you can have like a fraction that represents a whole, and then just by like changing the arrangement, like I don't know, like changing how it's set up, you can find a y value for where a whole would be in the graph, like.
Because you're finding a function that looks identical to it,
Right.
except without the whole there. By canceling that common factor, that's what you're doing. So what we're doing is like this function, say this function was f of x, okay? We did a bunch of totally legal algebra to get this function, 1 over the square root of x plus 2 plus 3.
Right.
Let's call this g of x. This function has a hole in it at 7. This function doesn't have a hole in it at 7. Other than that, the two functions are completely identical to one another.
So I'm finding a different function. I shouldn't think of it as like I'm finding a y value for like where the hole is. It's just a different function that like.
That doesn't have the hole.
Okay.
But that's really the same thing, right?
Right.
You're really finding, like, if this is a more complicated example. Let's look at the first one we did. If you look at the first one we did, this was the original function. This is the function we ended up with.
Right.
So that means that this function really just looks like radical x plus 2. It looks like this, except there's a hole in it at 4. So what we did is we just figured out what this function looks like without the hole. We found the y value, which is really finding the y coordinate of that hole.
So like we're going about it the same way. It's just like
Yeah.
the way I was thinking of it.
You get it? Okay. Let's just do one more of these just to practice here. How about this? The limit, this is a hard one. As x goes to 4 of x squared minus 16 over 2 minus radical x. All right, so what do you think you should do?
Like where you can do like x minus 4 and then plus 4.
Factor, yeah, sure.
Yeah. Well, yeah, but there's like a name for it, right?
Difference of two perfect squares.
Right. Yeah.
So let's do that. So x minus 4x plus 4. I still get 0 over 0. So what do you think next?
Multiply by the
Yeah, multiply by that thing, 2 plus radical x.
The bad thing.
And then only FOIL the bottom, because that's the part we're trying to rationalize. That's important. Only FOIL the part you're trying to rationalize. If you tried to FOIL out this top, it would make a mess, and you wouldn't get it right, because it would hide everything that you're trying to do, which is to create common factors. Remember, FOILing is like unfactoring something. So if you're trying to find common factors, why would you get rid of all these factors by FOILing? You know what I mean? That doesn't make any sense. So this ends up being the limit as x goes to 4. On top, I'm not going to FOIL. X minus 4, x plus 4, 2 plus radical x. And on bottom, when I FOIL, I get 4 minus x. Right? Does everybody see that? When you FOIL the bottom, you get 4 plus 2 radical x minus 2 radical x minus x. So now these cancel, but as a negative. Now there's no more problem. There's no zero denominator anymore. So if I substitute 4 in, I get negative 4 plus 4, which is 8, times 2 plus 2. So the answer is negative 32. So this is an example of one where you had to do both. You had to factor, and you also had to do this conjugate rationalization thing. You get it? Okay. That's all I got. So the homework is actually on IXL. I know that's popular with you guys.
Especially with these questions, it's going to be so painful.
It will be. I'm not going to lie.
I'm going to cry.
So the homework, it's just called finding limits involving factorization and rationalization. That's what it's called.
Is that posted on Classroom?
It's on Classroom, and it's also, if you go to recommended by my teacher in IXL, it's right there. It's highly recommended.
It's going to take me like 5 years.
Ever since we did IXL, English, I very much faster.
I've always hated IXL.
Yeah, sure.
It's evil.
Recommended.
I just hate the fact that like you can do like 300 questions and still have like a 4 as your score.
God, I'm telling you, 70.
And then like every question you do, it goes up like half a point. It just hurts.
Yeah, it does cause me a lot.
We have to get a 100 or a
The
93 or
first
whatever.
20 questions wrong, and then once you get
Just a 90.
one question right, it gives you like 1,000 points.
Oh, no challenge though?
That's true. That's your strategy.
Yeah, no, it does. No, it does work.
That's
You
a
just get a
twist.
bunch
You get a
wrong.
bunch wrong in a row, then it gives you super easy questions.
It also
and you
works
can
for
just get them
repeating
right, and then
questions.
you can
Just
like
like
memorize
1,000 questions wrong, because it's 0 effort, you just put gibberish. And then once you get a single question right, it gives you like huge reward.
Yeah.
Because it feels bad. It literally has an algorithm set up to pity you. That is
Wouldn't it
hilarious.
just be quicker to just get a couple right? You just get the score?
Yeah, but you can do it mindlessly while doing something else. You could watch YouTube while typing gibberish in the car.
Well, this is like the first one.
It's gonna be like 8th grade math.
I hate IXL so much. Like now that we've used Delta Math and it's like, oh, I can get it wrong one time and it tells me to like fix something. It's like so nice.
Yeah, this is-
It makes perfect sense.
This is like a
And it's
whole-
like,
It gives you examples of what to do and it's like right there, super convenient. Everything.
When you get IXL wrong, it's just like, here's another problem you have to figure out to just read what you did wrong.
Like, it's 2.
It hurts.
So you get 4t squared.
Yeah.
Or we have, assumptions where there's like 100 questions and it's still like.
You understand?
Yeah.
Dude, there was one time I was doing an IXL like the day before it was due for like Mrs. Hannigan or something. And I just kept I kept getting to like 90 and then getting one wrong. And I obviously had to have like a perfect score because I needed 100 on it. And I kept getting one wrong and it'd be like down to 60. And I got so mad. It's been like 2 hours. I literally just took my Chromebook and threw it against the wall and was like, I'm done. It was not good. I think I got like 2 wrong in a row. And I literally rage quit. I rage quit math.
Just combine all like terms.
It's, I don't know what the title of the section is, but it should be under, finding limits involving.
So now you can back it and take out a t.
It's F6. Hey, Mom, how much
Yeah,
did I
on the
pay
bottom.
you to do this?
Then you can substitute.
Honestly, might be worth it.
Sense?
Yes, it does.
Yeah, so don't forget, on IXL, you need to get a 90. A 90 is 100. But if you get an 89, then you're gonna get an 89. I'm not gonna be like, oh, if a 90 is 100, then an 89 must be a 99. No. An 89 is an 89.
Okay. My error. You ever like try to sing a song that's like this close to being in your range? Just like the tiniest, because that one note you just can't hit, and it hurts so bad. Because like in the chorus of the song that I was singing, like, and it goes into my head once, and like the entire song is in my chest, right? But then that one note, and I've tried like moving to different keys, it just doesn't. It just doesn't work. It's pretty painful.
I'm saying like a whole song like a hundred times. Just like, wait, I don't need to be doing this.
Well, like certain songs, you just like. I don't want to sing in my head voice for like a rock song. It just sounds dumb. Okay. Yeah, like my soprano voice. I'm like, rock music. It's so frilly. I can't stand it. I can't go that low. I should learn how to metal scream.
Yeah, that'd be
What's up?
So,
I think that'd be pretty cool. It's like really hard, but apparently it's not as hard on like harsh on your voice as people think it is because it's not in your voice box. It's like below it. Like it's like a guttural thing.
Okay, so it's that remaining.
There's voice box.
So it's not gonna be one over anything.
It would be 1 over 4 times.
It's like almost
Oh,
everything,
okay,
but not
yeah,
quite.
start with like, then you, then I have.
Yeah.
Yeah. Try reading the song.
I don't want to mess up your score.
It's just like trying to sing sometime and it's just like, yeah, I can't do that.
Yeah, I
Yeah,
try.
okay, good stuff.
The thing is, I listen
It
to
should actually be.
mostly rock and mostly male lead vocalists. So like basically everything I like is really difficult for me to sing. I mean, I can sing, some stupid choral music if you want, but I hate it. I hate it so much. I can sing pop music. I can do Katy Perry, BS. That makes people happy. I don't either. Ever since she had that interview with Neil deGrasse Tyson, and she's like, "Is math related to science?" I was like, "Oh God."
So like, I
She's not. She's a bit vapid. Yeah.
Two songs I like.
I think the Katy Perry album was like the first CD I ever had. Yeah, Teenage Dream.
I don't say yeah, Teenage Dream.
That was the first CD I ever had. I think I still have it somewhere. My mom gave it to me. I don't use it anymore. This was like a Taylor Swift CD.
Which one?
I don't remember which one it was. It was the one with like the choose, you know the song where it's like she's cheer captain and I'm on the blue shoes. Think about the day when you wake up and find that what you're looking for has been here the whole time.
Fearless.
Yeah, that song. That's the one. It's the album with that one.
That's what the album's called.
Oh, okay. I thought it was a song. Okay.
Sure, it is a song, but yeah. That's what the song is called. That's what the song is called. You want to think? Yeah. She's like, what's a very different song.
At the end where he like composes and everything. Yeah. That's the music I listened to before everything.
Okay. So is this one gonna
The
be?
day I discovered that music could exist outside the radio.
Yeah.
Yeah, no, I was okay. So I was literally listening to like some 21 Pilots song in like the radio or something when I was like 11, and I was like, "This is really good." So I like looked it up, and then I saw like all the pieces. What? Yeah.
But it's good.
And then I descended into my emo
Well,
phase.
they
go away.
They don't
And I
go
never
away,
left.
they cancel as one. When things cancel, they don't.
I think I
cancel
was a
as
late
one.
bloomer.
They cancel as one.
Yes. iPods that are like this big.
Dude, I remember those little tiny things.
iPod Nano.
I had pink songs on those.
I have like Kids Bop and Taylor Swift. Kids Bop.
No, it was all pink. I had like a pink.
No, I love that.
I've changed so much. I don't even recognize like that version of myself. I don't sympathize with it at all. It didn't happen. So what music do you listen to like casually?
Yeah, love it and stuff.
Like what?
Just like anything, I don't know. We're just like put on Spotify and see what happens.
Well, I go to Spotify,
Well,
so that's problem number one. Sometimes I just buy CDs because they look cool.
I mean, I do shit.
Yeah, and then I'm like, sure, I'll give them a try.
I love to go to thrift stores. My sister got me a record player a few years ago. I just love to go to thrift stores and buy like a ton of like $1 records and see what's going on. Usually it's like really bad classical music.
Oh.
I love it. It makes me so happy.
It's really fun.
Or it's like with weird like polka music.
Try it out now.
Because one record that's polka music and on the inside it like teaches you how to do all these dances.
That's amazing.
Yeah, it's really cool.
Polka music. I don't think I've ever listened to polka music.
They're so fun.
I'm just imagining like Weird Al Yankovic, but like an entire genre. But it's not ironic or funny. Are polka dots and polka music related? Yes. But like how and
They're like, what is the polka? They're like cousins.
but how and why? Like was that just a thing that they invented like for people to wear when they dance to polka music? Like they're like, oh yes, we're gonna be in circles and they're gonna be called polka dots.
Well, maybe it has like something to do with the buttons on the accordion.
Maybe.
Because those could kind of look like polka dots.
I mean, it depends on the accordion.
And
Some of them, yes.
yeah.
Some of them, no.
And the accordion is like what's the major part
No,
of the polka music.
Sarah, this needs to be answered. These are important
They're
questions.
all flocked. I don't understand.
No polka in this school. I feel like basically every song I listen to is blocked like within a week of me listening to it on this one program. It's like, what is Bailey listening to? Yeah, she can't. No, that can't be good. Yeah, whatever she's looking at.
That's what I did. Factored it, and then I would have got it.
The factoring is wrong. This factors as x minus 5x minus 5.
Does that have the answer?
Oh, it, no.
Two numbers
This is the
multiplied
break
between
between
25 and 90.
No, just ask where polka dots came from.
So negative is, so this would be,
Are
so then when they cancel,
European folk art, but they have
that
different wires
cancels
of
with that.
that.
you just left with x.
Well,
Why are they?
It's folk art?
Yeah.
Dots are folk art.
Oh, is it?
So now you
Well,
can
the music is
substitute
like
5 in.
European folk
So
music.
the answer is 10.
But what does that mean, folk art, when you draw like a
Does that make
circle
sense?
and you color it in, you're like, yep.
Okay, so if you subtract 25 into
Sure
0, 0.
Yeah.
And in fact, that's this part of it,
Oh,
right?
yes.
Cancel common factor.
It's a statement,
Which
Tommy.
leaves you with this.
Okay, so
And
it's.
then
polka
the
dots
process,
are-
in every
Yeah, but like, if it's so
process
widely
is,
popularized,
once
it's
you cancel
no
this
longer.
out, plug the number back in, see if it works. And it does, good job. And that's the
Obviously, I'm thinking of now.
Pardon me, but early if you're in formal context, it is generally confined to one place.
I seriously doubt that they were like, contemplating like the action
Yeah,
or
exactly.
trying to transform like a noun into a verb by creating a dot and being like, what is? Like, I really doubt they were thinking about that while making polka music.
I bet they were.
I seriously doubt it. Maybe polka music is just all a meme. Maybe it's like 8 layers of irony.
This type of thing.
What is that?
This is where you.
Yeah, but there's-
So multiply the top and bottom.
This is what I mean, but
I've never seen it.
Yeah, multiply top and bottom by radical x plus 1.
Teach me how to thug.
Yeah, I don't know.
I don't either. And I don't know how to do anything, especially when it comes to dancing. When I dance, I just headbang really hard and just like play guitar.
There was one time that I was in a park.
That's how I dance.
I was
Well, for the
like
top.
hanging in the car next to us, and he was like kind of like not normally headbanging, he was like fasting in a weird way.
That's how I
And, like,
it's fun.
And my mom and I were like genuinely concerned that he was.
Okay, well, sometimes when you're in the car and you're like
we opened
headbanging.
the door and we heard the music and we were like. I was like, we were like this close to being like 911 question.
When you're listening to that kind of music, if you're like in the car, you can like bounce yourself against like the car seat, and it just like makes you look like you're having a seizure. But it's really fun. It's a really fun seizure. Probably my favorite. Yeah, the seizures I've had, as numerous as those that. That's my favorite.
Bailey, I think Tommy's trying to show you something.
Yoel Kusama, a renowned artist who works extensively in polka dots.
One, 1. Radical 1 is 1.
So she started her work. She's like, you letting me to light.
You're welcome.
No, I hate Queen. What? You hate Queen? I kind of love how sometimes the ballet but yeah, that's
Have a good weekend, guys. See you later.
Thank you. Have a great weekend. Thank you so much.
Thanks. See you. Hey, how's it going? Good.
I have a lesson.
Okay,
I might be back. I don't really know.
make sure you watch the video because it's doing something a little complicated today.
Okay.
Okay.
Thank you.
Yep.
What if I run to the bathroom?
So go ahead.